Prince George's County Alumni Chapter of Delta Sigma Theta Sorority Incorporated presents the Science and Everyday Experiences STEM at Home video series.
Welcome to the Prince George's County Alumni Chapter, Delta Sigma Theta Sorority Incorporated STEM at Home video series. Brought to you by the Science and Everyday Experiences Committee. My name is Soror Anita Walls, and today we are going to focus on an area of science called physics. Physics is the study of the basic principles that govern our physical world. Energy and matter, everything that we're made up of. There are many topics in this area of science, but today we're going to focus on one area, the motion of the circle, and the force that makes a circle and the motion that we find in a circle happen, centripetal force. So what is a force? That's the first thing we need to know. Simply put, a force is a push or a pull. Okay, a push or a pull that acts on an object that might make it move. Forces are all around us and affect us no matter what we are doing, even when we are sleeping. A force can be used to change the direction of an object, make an object go faster or slower, and also make things fall. Not all forces can be seen, but a force always has a particular strength and acts in a particular direction. So one force everyone knows about is gravity. We can't see gravity, but gravity is one type of force that affects the whole world. If you jump up, you're going to come back down. That's gravity. Gravity pulls things down to the earth. Another force that we all use or come in contact with every day is friction. Friction is the force that slows down or stops things from moving. It happens when two objects rub together. If you take your hands and you rub them together, you'll feel them starting to warm up. When you're riding your bike and you step on the brakes, it's warming up. When your parents drive their car and they step on the brakes, two things rub together, causing friction to slow down and stop the car. But today's force we're going to be talking about is centripetal force. And what is centripetal force? Centripetal force is a force that makes an object travel in a circle. The force is towards the center, what we call center seeking. It's always directed towards the center of the circle. So, centripetal force, when the circle goes around, it travels around, and a circle is created because there's something to push the marble back toward the center. But if that wasn't there, the marble would travel in a straight line because there's nothing to stop it from going in that straight line and continuing in a circle. When an object moves in a circle, it is always or constantly changing directions and speed, what we call acceleration. We cannot see this acceleration because it is balanced by the pull away from the center, as you saw on the plate. Without centripetal force, an object cannot move in a circle. It will only travel in a straight line until something gets in its way. Think of some objects that move in a circle. Some objects that move in a circle are roller coasters with the loop part, because you start off in a straight line, and then when you hit the loop, it's in a big circle. Merry-go-round. If you've ever used a hula hoop, spinning tops. If you've ever seen a helicopter, the blades spin and it's attached to the center. So it spins in a circle. And what about at your home? If you've ever seen a washing machine, when a washing machine spins, it is center seeking. So if you think about centripetal force, I want you to think about spinning things, okay? So one of the things that spins that we all know about is our planet. Planets are kept in their orbits by centripetal force. Centripetal force is caused by gravity, and in a similar way, satellites orbit the Earth. Okay? This is the gravitational force of attraction between objects causing centripetal force. The moon is kept in orbit around the Earth through centripetal force caused by the constant pull and the gravitational forces pull between the moon and the Earth. So, as I said before, a force is a push or a pull. If the gravitational pull were to stop, the moon would shoot off in a straight line. If you've ever traveled in a traffic circle in a car, cars experience centripetal force when they're in the traffic circle. You can feel yourself leaning as the car turns because it is center seeking and you're being pushed out. If the door was open, you would fly out in a straight line. But because the door is closed, you continue in the circle along with the car. Okay? So when you're out traveling and you're in the car and the car is going through dips and hoods and you're in a traffic circle, I want you to think about centripetal force. Okay? When you get up in the morning or you're doing things at home, think about how centripetal force impacts you every day. So these are just a few quick examples of centripetal force at work in our everyday lives. Whenever an object moves in a circular path, the object is accelerating because the velocity is constantly changing directions. The special force at work is called centripetal force, a center-seeking force, which means that the force is always directed towards the center of the circle. Without this, it just continues moving in a straight line. So let's explore centripetal force real quick. So as you see here, I have a cup full of marbles, and we talked about the force of gravity. So what do you think? I have a cup and I tied a string through it. You can see that? It was just a regular cup. And I found some marbles laying around at home. Since we are science and everyday experiences, we use everyday things. So if I spun this cup in a circle, what do you think would happen to the marbles? Do you think they would fall out when the cup turns upside down? So if I take this cup and I turn it upside down, we can see that gravity pulls the marbles out of the cup. So they fall into the other cup. But what if I spun this cup in a circle? Would the marbles stay in or would they fall out? Let's find out, because this is an example of centripetal force and how we get circular motion. The marbles. So if I start swinging it, if I swing it too slow, the marbles might fall out. If I spring it fast enough, the constant changing speed, the marbles should stay in. So let's see. I'm going to spin the cup. And the marbles stay in. The marbles want to travel in a circle. Okay? The marbles want to travel in a straight line. So if I had cut a hole in the cup that the marbles could fit through, they would fly out in a straight line. But the cup stops the marbles, so they can only choose to travel in a circle. Okay? This is the same effect you feel in a car, right? So the marbles stay in the cup as the cup spins. This is a demonstration of Newton's first law of motion, that objects either remain still or move in a straight line. The reason it's able to travel in a circle is because of the pull on the string that keeps it in constant motion. Okay? So we talked about gravity and centripetal force. Okay, you have to have a push or a pull to make it change from a straight line to circular motion. When you swing the cup back and forth, I could feel the marbles inside pulling because it wants to continue in a straight line. I want it to go in the circle, so I hold on to the string and make it go into a circle so it doesn't fly away. When you swing the cup upside down, gravity tries to pull the marbles out of the cup. Centripetal force tries to keep them in the cup. Whichever one wins will determine what happens. If gravity is stronger, then the marbles come out of the cup. If centripetal force is stronger, then the marbles stay in the cup as it travels in a circle. Okay? So those two things work together. We're also going to look at a second experiment for centripetal force using just a balloon and a penny. Okay? So we're going to take a balloon, we're going to take a penny and put it through the neck of the balloon. This is a simple way to explore centripetal force. We take the balloon and we blow it up. And then I can ask you the question, can this penny travel in a circle? The answer would be yes. Why? Because the sides of the balloon will stop the penny from going in a straight line. So if we start turning the balloon, I don't know if you can see that, but the penny travels in a circle on the inside of the balloon. The centripetal force, the inward force on a body that causes an object to move in a circle, affects the penny. The shape of the balloon makes the penny move on this circular path. There's very little friction along the edge of this, so you can't hear the penny move. You can only see the penny move. So the penny is constantly seeking its own center. Our next experiment will also use a balloon and a hex nut. A hex nut is a six-sided nut that you can buy at the hardware store or the dollar store. Okay? So you take the hex nut and you put it inside the balloon. Okay? And then you blow it up. And inside your balloon is just the hex nut. Now, this is also going to be center seeking. The hex nut is going to seek the center. But unlike the experiment with the penny, there will be friction in this. So we'll get a different take on this, okay? So once you start, you're trying to get the hex nut to go in a circle. You know it's going in a circle once it starts whistling. So, like the penny, the hex nut is center seeking. Your ears register the sound as soon as the hex nut is traveling in a circle. So, the shape of the balloon makes the hex nut travel in a circular path. Otherwise, the hex nut will want to continue to move in a straight line. Why does the hex nut make a whistling sound when the penny does not? It's because of the six sides of it. Those six sides of the hex nut move around the inside of the balloon, and the flat edges make the hex nut bounce around. But once it starts spinning in the balloon, the friction on the six sides causes the whistling to occur from the vibration. Okay? So one more time. And just like the penny, it's center seeking. A simple way to see centripetal force at work. So science is all around us. Centripetal force affects us from the time we wake up to the time we go to bed. Spend some time today and see how often centripetal force impacts your day.